All right, let's jump right into this. In today's Explainer, we're unpacking one of the most incredible and honestly heart-wrenching stories in the entire history of American science. We're looking at the epic rise and the catastrophic fall of the Arecibo Observatory. For nearly 6 decades, this thing was humanity's greatest ear to the cosmos. It was a structure so massive, so iconic, you just kind of felt like it would be there forever. But as we're about to see, even giants can fall.
Picture this. It's the early hours of December 1st, 2020. 7:56 in the morning, to be exact. High above the lush Puerto Rican jungle, a cluster of steel cables suddenly gives way without any warning. And in less than 10 seconds, a 900-ton instrument platform, this massive apparatus that had hovered securely up there for nearly 60 years, just lurches forward and plunges 492 feet. It slams right into the gigantic reflector dish below, shattering thousands of aluminum panels and sending this massive shockwave of debris rolling through the jungle. Just like that, the most productive radio telescope in the history of science was just gone, swallowed up by the very dish it had spent decades suspended above.
And when the drone footage of this terrifying, completely uncontrolled collapse circulated online, the response from the global scientific community was immediate, and it was deeply visceral. Scientists who had literally spent their entire careers working at Arecibo described watching that footage as being like witnessing death. I mean, this wasn't just a building falling down, this was the loss of an absolute icon, an irreplaceable tool for discovery. So how did we get here? How on earth did the United States let the world's most powerful radio telescope simply fall apart?
Well, that brings us to part 1, a secret Cold War solution.
To really understand how we got to that collapse, we gotta rewind all the way to the late 1950s. There was this Cornell physicist, William E. Gordon, and he had this wild idea to fire a radar signal straight up to map the ionosphere. You know, that charged uppermost layer of Earth's atmosphere? But the math required a truly massive scale. To do the job Gordon imagined, at the specific frequencies he needed, the receiving antenna had to be roughly 1,000 feet across. 1,000 feet! To put that into perspective, that is wider than the Empire State Building is tall. At the time, conventional radio telescopes were built as rigid, dish-shaped structures mounted on gimbals so they could physically tilt and rotate around to scan the sky. Building a rigid moving dish 1,000 feet wide, structurally impossible. It would literally collapse under its own weight.
But Gordon had a real stroke of genius. He realized he didn't actually need to move the dish at all. Instead, he proposed this incredibly elegant 3-step engineering workaround. Step 1. Find a massive, naturally occurring sinkhole. Step 2. Build a spherical reflector dish permanently fixed right into the contour of the ground. And Step 3. Suspend the receiving instruments high above it on a movable platform. By just repositioning that platform overhead along the arc of the dish, it could collect signals arriving from completely different angles of the sky, all without the giant dish ever having to budge a single inch. It was brilliant. They ended up finding the perfect limestone sinkhole in northern Puerto Rico near a town called Arecibo.
Now you might be wondering, who exactly writes a $9 million check to build a giant radar in the middle of a tropical jungle? The Department of Defense. Specifically, the Advanced Research Projects Agency, or ARPA. You see, this whole project came with a highly classified Cold War motivation. Intercontinental ballistic missiles, or ICBMs, follow trajectories right through the ionosphere. Understanding exactly how that electrically charged atmospheric layer affected the guidance systems of incoming atomic warheads was militarily urgent. So ARPA funded the operation from day one, and by 1963, Arecibo was fully operational.
Which leads us to part 2, rewriting the textbooks.
So, Arecibo was originally built for the military to monitor the ionosphere, right? But almost immediately, it started listening to other things. By 1969, ownership of the telescope was handed over from the DoD to the National Science Foundation, and its civilian impact was just staggering right out of the gate. In 1964, a team pointed that massive dish at Mercury to measure its rotation. Now, at the time, every single astronomy textbook in the world confidently stated that a day on Mercury was 88 Earth days long. The consensus was that it was tidally locked, with one face permanently pointed at the sun. But Arecibo's radar pierced through the noise and proved the actual rotation period was 59 days. Within months of powering on, Arecibo forced the scientific community to literally rewrite the textbooks on our inner solar system.
But to understand Arecibo's most dramatic triumph, we have to talk about pulsars. So what is a pulsar? It's basically the extremely dense, collapsed core of a dead star. They spin incredibly fast and shoot out radio pulses with the strict, predictable regularity of a metronome. In the summer of 1974, a 24-year-old Cornell grad student named Russell Hulse was using Arecibo to catalog these objects, but he found one that was just misbehaving. The pulse timing kept drifting in this strange, shifting pattern that made absolutely no sense for a lone spinning star.
So Hulse and his advisor Joseph Taylor crunched the math and realized what Arecibo had actually found. The pulsar wasn't alone. It was locked in a tight, violently fast orbit with another neutron star. The two objects circling each other were what was distorting the signal. They tracked this binary pulsar for years and confirmed its orbit was decaying at the exact rate predicted by Albert Einstein's general theory of relativity. They delivered the very first actual proof that invisible ripples in spacetime, gravitational waves, were real. This wasn't just some abstract math equation, it fundamentally changed how we understand the fabric of the universe itself. It was a monumental discovery made possible entirely by Arecibo, and it rightfully earned them a Nobel Prize. But here is the really cool part. Arecibo wasn't content just listening inward, it also spoke outward. In November 1974, scientists utilized an upgrade to the dish to broadcast a 1,679-bit radio message deep into space, aimed 25,000 light-years away. It contained a primitive image of our solar system, a human figure, and a little pixelated image of the telescope itself. It was the most deliberate attempt humanity had ever made to announce our existence to the universe. And man, this completely captured the public's imagination globally. Soon enough, Arecibo was starring as a concealed Soviet installation in the James Bond film GoldenEye, and it was featured prominently in Carl Sagan's Contact. It became this universal symbol of humanity reaching out and listening to the cosmos.
But, of course, nothing lasts forever. Welcome to Part 3, The Slow Decay.
In a really bitter irony, just as the world fell in love with Arecibo through pop culture, its lifeline was quietly being severed behind the scenes. In 2006, the National Science Foundation implemented broad budget cuts. Arecibo's annual funding was slashed from $10.5 million down to $8 million. The NSF essentially told Arecibo to go find outside partners to share the operational costs. But sadly, no knight in shining armor ever emerged. The budgets just kept getting stretched thinner and thinner, leaving this massive, complex piece of hardware critically under-maintained year after year. It was a complete recipe for disaster.
And then, nature accelerated the demise. In September 2017, Hurricane Maria slammed into Puerto Rico. The storm's eye passed directly over the observatory, just battering it with 155-mile-per-hour winds. A heavy-line feed antenna tore loose and plunged right through the dish, destroying roughly 30 of the 40,000 aluminum panels. While the dish did largely survive, it was severely battered. Shockingly, the NSF responded by announcing a plan to ramp down funding even further, proposing to drop it to just $2 million annually over the next 5 years. The writing was clearly on the wall.
Which leads us to the grim finale, Part 4, Anatomy of a Failure.
By 2020, years of deferred maintenance, those relentless budget cuts, and the harsh realities of a humid tropical environment finally caught up with the brilliant engineering. On August 10th, a secondary cable on Tower 4 simply slipped free from its socket, crashing down and tearing a 100-foot gash through the dish. Now, engineers initially thought it was manageable, but then, on November 6th, one of the main support cables on that exact same tower suddenly snapped without warning. Now, 2 cables were gone, placing this massive, unrated strain on the remaining lines. Structural engineers quickly realized a catastrophic collapse was likely. On November 19th, the NSF announced the observatory would have to be decommissioned. But fate wouldn't even wait for a controlled demolition, because on December 1st, it all came crashing down.
Independent investigations later revealed the true microscopic culprit behind the disaster. It wasn't just the hurricane or a single rusty wire. The root cause was something called zinc creep. Over decades, the zinc poured into the cable socket fitting slowly, almost invisibly, deformed under the extreme, sustained weight of that 900-ton platform. Add in a highly humid tropical environment and original design margins that actually turned out to be thinner than engineers initially realized, and failure was guaranteed. It had literally been failing for years, but visual inspections could never have caught it.
The aftermath was a harsh reality check. In 2022, the National Science Foundation formally announced that the mighty Arecibo telescope would not be rebuilt. While an educational visitor facility is going to be established on the site to honor its legacy, the Great Dish itself, the one that rewrote textbooks and proved Einstein right, has just been left in its sinkhole. Today, it sits cracked and overgrown, slowly returning to the Puerto Rican jungle from which it was born.
Which brings us to the final, lingering thought of this explainer. The fall of Arecibo wasn't just an engineering failure, it was a choice, one driven by decades of financial neglect. As its ruins fade back into the jungle, we really have to ask ourselves,
What cosmic whispers are passing by the Earth right now, completely undetected, simply because we let our greatest ear to the universe go deaf? Thank you so much for walking through this incredible story with me. Keep wondering, keep asking questions, and I'll catch you in the next explainer.